Okay, so welcome to Cute Analysis. So the first and most important concept that we need to establish in this course is the concept of a symbol. So because we're abstracting the subjective and physical meaning of what it means to be cute, what we're doing is instead making it a symbol and then sort of assigning some other mathematical object to it which we abstract to be your crush. So um, so the first thing that we want to construct is E, which is our English language, which will contain every possible word that you can form, and that includes the word cute. So first we want to construct E. So note that this is just going to be the Latin alphabet, and it will just contain the letters A through Z. And if you somehow have a crush whose name has characters that are outside the Latin alphabet, just construct a new language and then sort of just apply total ordering like I will today. So let's start the construction. So first, take into consideration the set A, B, C, orbital X, Y, and Z. Now these aren't actually letters, they're just symbols, they are just symbols. That's all they are right now. And this set so far is unordered. Actually, all sets are unordered. I can swap A and B and it wouldn't do a thing. I can swap A and C, X and Z, and it wouldn't do anything. But what we want to do next is apply total ordering to this. What we mean by total order is that I can order these elements, actually linear order to be more specific. What I can do is take elements, two elements or more from the set, and then say that one is less than the other. Okay? So I can say that A is less than B, or A comes before B. I already did this in a previous lecture, but I will be restating it for this theory. Okay? So in order to do that, we need to define a binary map. Well, prep equal. And if I let this thing here be my language L, then this binary operator takes L, cross L, and then maps it to some prep of L. And the specific map for this is that for any symbol A inside this L and any symbol B inside our language, it holds that A and B are comparable. That's what we mean. So A can be less than B, or B can be less than A. Okay? For any symbol A and B inside L. Okay. So, now that we have some notion of ordering, what we want to do next is create a new set that sort of labels each number and assigns to each number, each symbol, a number, a natural number, or a counting number that is ordered. So, what I did in that lecture was to take the Cartesian product of L and the first 26 letters of, or the first 26 letter numbers of the naturals, or the first 26 elements of the naturals. And I don't mean this in the usual sense of the Cartesian product. I specifically defined it to be a new set of ordered pairs. So a new L dash is equal to A grouped with the letter 1. Notice that this n here is not n star because n star includes 0. Okay, you guys can debate all you want about 0 being a natural number or not, but we will start from 1. Okay, A1, B2, and then all the way up to X24 and Y25 and Z26. Okay, so the reason why I want to make it an ordered pair this time instead of just sets is because I want to reinforce the notion that on the left it's going to be the symbol, and on the right it's going to be its position inside our ordered set. So the last thing we need to do in this construction, in order to make E, we define E, our English alphabet, to be the equipping of this set, L dash with prep equal. And there's our English language. Okay. So yeah. So A is the first letter, B is the second letter, up until Z. So this is called lexicographical ordering, or linear order. Okay. So now that we've done this, wait, this is L dash. Okay. So we have this. What we want to do next, because right now all we have here are symbols, right? Actually, in this L dash here, we can just define each ordered pair to be just the letter that's inside them. So this ordered pair A1 is just A, B2 is just B, and then so on and so forth. Okay. So yeah, just know that if I do write this to be A, B, C, D, it implies a bunch of ordered pairs. Okay. So now that we have constructed this and our English alphabet, ordered English alphabet, what I want to do next is create or generate a free group over all of this so that we have a bunch of words. So what I mean by a free group now is a group, of course, that has an operation. So the operation here is concatenation or string concatenation. I know when you try to search that online, it will just give you something that's related to computer science. But concatenation is a very important thing in mathematics, especially algebraic topology, which we will be employing later on this course. But the point is, what I want to do is now construct the entirety of the English language by stringing these symbols together. Okay. So, if I have these guys, so I can make a presentation or group presentation for this free group. And that group presentation will be precisely A, B, C, and up until X, Y, Z. That's it. That's all I have to write here. But of course, each of these A's correspond, or each of these letters correspond to an ordered pair, so that we know that these letters cannot be commuted and that they are what they are. So A is still A, and it is the first letter in the alphabet, and Z is still Z, and it is the last letter in the alphabet. Okay. So there is no defining relation for these guys, so I'm not gonna have to write a vertical line here and then an equation. Okay. All you have to guys know is that the group, right, the free group, which is every possible thing I can string from these letters, is generated by these generators or these symbols. And this is just a presentation. So the actual group would be it would be every possible word you can think of, every possible English word you can think of that's formed from these letters. So and or maybe even of course the word cute is inside this free group, and I will denote this free group as F sub E, and we will be employing this structure. Okay, we will be employing this structure throughout the entire course, especially the use of the word cute, because after all, this is cute analysis. So, yeah, this is a very important structure inside our theory, and yeah, and also your crush name will be inside this free group. All right. So it's gonna be in here. All right. What else can I say about this free group? Well, of course, this is a binary operator. This implies a binary operator, which is the concatenation. It could be an n-ary operation, like you can take multiple symbols and then put them together, but it's mostly just binary. Because if I take two symbols here, say X and Z, I put them together, right? That's a binary operator. I take two inputs Z. And then what if you want to consider like maybe putting three symbols together? Well, that's just doing this and then putting in that third one, say A. It's still a binary one. Still a binary operation because this becomes one element and then we're composing it or concatenating it with another element. So it's still binary. So we can of course we can degenerate the operation from an n-ary operation into just a binary operation. So it's easy to understand or more intuitive. So there. Very important concept. Again. I can't stress enough how important this concept is to our theory. So in the next lecture, we will be diving into group theory, and that's going to be the first like official lecture. This is just like an important prerequisite. We will be discussing about group theory next time, and cyclic groups or modular groups. So yeah. Any questions? None? Kyle got questions? Nicolo got questions? Nicolo, got any questions? No? What am I doing? You should really check out my channel.
Cluing, you know.
Why?
Yeah. Rene, are you sure that's a good idea, what you're doing?
Yes, it is a good idea. This is in general, by the way. I'm not hinting towards anyone.
Alright.
Anyone?
Yeah, this is in gen, like anyone can use this theory. Anyone can use this theory.
But
If you have a
the
crush,
way-
you could use
the
it.
way you were teaching us was something different.
No, it's not. If you see the
Do
introduction.
you have a PDF copy of whatever the fuck you're talking about right now?
Yes, the introduction.
Just the introduction.
No, in the introduction, the paper is there.
Okay, good. Subpoena that later on.
Do you know my channel?
Huh?
Do you know my channel? It's in the introduction. Professor Femmy, if you will.
Professor what?
Femmy, Femmy. That's all you need to know. If you check the introduction, you will see the paper there. Or it's gonna be linked in the sort of it's gonna be a link to Overleaf, but the paper's there. So yeah. Any more questions? That is not. That's related to the lecture. Yes.
Why did you bring him up there?
What
Why
did I
did you bring her up there?
bring
To
what?
the lesson.
What about it? What?
Why did you say something like, if your crush has a Latin letter, blah 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 blah?
No, I'm just saying that if your crush contains like, if your crush's name has letters that are outside.
Hi guys, do any of you have a lab code?
Hello.
Didn't you have an extra?
I only have extra for so
Oh, that sucks. We
have
were
all?
given lab coat.
Yeah. Anyway,
Actually,
I was just saying a while ago that if your crush has like a name that has like letters in it that's not in the English alphabet, just make a new language or a new one where it's included, and then just apply what I did a while ago.
Can you write the letter E?
Huh?
Can you write the letter E?
This is a
Again.
different type of E. Like,
Okay, yeah, write the letter E.
the reason why I wrote E is because it's English. E, English.
Here.
I'm not trying to hint towards
I'm
anything.
not judging you.
All right. So that's a good place to stop.